Welcome to Kaylor Motor Works. Well, we're back again. I went ahead and hooked up the 48 volt 500 amp controller to the compound motor that we picked up for the Kaylor adapter, and everything is working fine. So let's have a look at the computer. It's not a whole lot of parameters you can change, but there's a few. So that's kind of where this is at. It's so it has a value of 4. I can change it, and it depends on the voltage. It's a low voltage system, 36, 24, or 48. So it depends on what number I can put there. We'll tell it what the pack voltage is, and then the under voltage stuff. And then you go to the current, main current limit, 500 amps, so I can limit it to 200. Plug current limit is 125 amps, so I can't go any higher than 125 amps. Speed, acceleration rate 2 seconds, max speed 100, rev speed 100. So I can control that. And then throttle depends on what throttle I have. So I have a 0 throttle, 0 to 5. Dead band, throttle max, and throttle map 50%. And then I have miscellaneous, variable plug braking, contactor protection on, menu drop delay 0. So it's got a few things here, but very basic, and it comes already with a basic setting. And then I can do some plug braking. I can monitor plug braking. So right now I'm at battery voltage here. Down here is 55.6 volts right in here. And so that's what I'm running at the moment. So motor voltage 0. So if I hit the throttle, you'd see actually how many volts are actually going to the motor. So we're going to do that here in just a second. And as soon as I can grab my throttle pot here. So motor voltage. You're going to see right here above the arrow. So right now the motor's running at 2 volts. So amazing that it can run on 2 volts. So 4 volts, 5 volts, 6, 7, and that's motor voltage. Duty cycle is only 18%, so it's off. It's only on 18% of the time at 9 volts. So that shows you how many, you don't use a lot of volts. It'd be higher voltage once we get a load on it, but for and also you can see over in the side on the right, you can see the voltage there because that's what I'm monitoring. So we'll shut that off. Duty cycle, throttle. Motor open, it's off. So anyway, so we're just gonna kind of have a look over on the right. So throttle's at 9%, duty cycle's 9% at 3.9 volts. And you can see the motor there in the background running. Cool. So it's not wanting to focus in on there right now, but you can see the motor spinning. "26 volts. Thing's running nice. It's gonna be a nice little setup. Then I'll figure out plug braking, see if I can take advantage of some plug braking. But anyway, that's the computer. So we're gonna put the computer away for now. So I'm just gonna log out of there, shut my old computer down. So over here on the right, oh, amperage. You know, I can probably figure out what kind of amperage we're doing too. So let's get down, get a little bit closer, see what kind of amps we're pulling. Probably very little. Down. So you'll see down here, .7, 5.6, yeah. You can see the controller over to the right, motor, battery pack to the left, and so I can only use half of this pack here. It's 48 volt setup, and so, and contactor down in front there, and I have a 12 volt battery right there to power the contactor. I don't have the DC, that's for the lawnmower. Okay, so let's run this little guy up. So this thing is really sensitive compared to the other setup. Alright, so now we know that the motor is working really well with modern contact or modern controller. I have even a better controller that we're going to use in the car, because we're going to go all the way up to 96 volts. And I could probably even go higher. I could probably even do 144 volts with this thing. And if I do, this thing's probably going to rip pretty good. So we'll see. We'll start out at 96, and I think that will be good. And so let's see here. Yeah. So this battery pack here, once it's all set up and everything's balanced, everything's done, is a 96 volt setup, and that will work. And 3 sections is 144. So this one was done with a single section, and I can run this. I could probably drive the car at 48 volts with this motor with no problem. What's interesting is the other controller I have is a synchromotive controller. It's a DC motor controller. It's fairly robust. It'll go all the way up to 196 volts and 950 amps. I'm not going to take it that high. But the unique thing about it, set up properly, which I've already done, is it is also not just a controller, but it's also a charger. It's built in, baked into the cake. And so what's neat about it is that you can connect solar panels directly to the controller. Just plug it in, and it will charge your car from the solar panels, whether they're producing a lot of power or a little power. And as long as the voltage from your panels is less than the low voltage that you're charging, it will take the low voltage and bump it up. And it works. It works really well. And it also is a constant current, constant voltage setup. So once it gets to voltage, it'll hold the voltage until the current drops. And so it's a pretty neat little setup. So I could go 96 volts on this, charge off my solar panels, off a bank of solar panels directly, just direct. I could have a set of solar panels out in the yard, not connected to anything, and charge my car directly with it. And it will shut itself off when it's done. Pretty cool. But for now, what I need to do now is I need to get that pressure plate off of the flywheel. It's a little rusty. May still actually work, because it was mounted in the transmission for a long time, so it may still function. But I think I might want to put a newer pressure plate on there, a little bit more robust. And then if I can, the coupler that couples the adapter to the motor and flywheel to the motor, it's probably just a 4-pin Volkswagen, and I want to see if I can send it somewhere and have somebody make it into an 8-pin, so I can put an 8-pin flywheel, because this thing has just a crap load of torque, and I'm not sure I want to stick with a 4-pin unless I keep it low voltage. If I keep it really low voltage, it'll be all right. So anyway, enough with chit-chatting. This is now a fully functional test of a 48 volt, 36 or 48 volt, 500 amp Curtis clone controller to the Kaylor China Motor compound wound shunt series motor, and 48 volts from this front part of this battery pack. Nissan Leaf modules, no less. Nissan Leaf modules are awesome. They can handle a lot of abuse. These are the older version. I have newer ones. But my lawnmower went all the way down to not quite 0 and bounced right back. No problem. Everything's working just fine. Holding voltage, nothing's leaking, nothing's heating up. Everything's working as it should. And here we go. Let's get rocking and rolling. And I'm going to leave the patina of the motor and adapter because it was just the way it was a long time ago. And we'll just plug it in, see how it does in the car. If everything works good and we want to keep it in the car, then we might clean it up. Otherwise, if it goes in the bus has got a lot of patina, well, we'll just leave some patina on the motor and adapter plate too. And I am hoping to get a hold of Roy Kaylor again. He's about 87 years old. He does live up in Oregon. And if I can get through to the old guy, I'm going to let him know that I've got one of his China motors working in a car. And I also have a hybrid engine, but I'm not sure that's going to work. But for now, we've just got this China motor, which I've been looking for, and it was in his advertising in one of the brochures booklets that I have. And it's definitely China motor, and it is bigger than it looks in the book. And it definitely has some grunt, and that's what I like. So, we'll talk to y'all later. Thanks for watching again.